Hey there, Will. What are you reading?
Hey, this Shakespeare's
Really?
Twelfth Night. Yep. I was interested in this quote from Malvolio in Act 2. Be not afraid of greatness. Some are born great, some achieve greatness, and others have greatness thrust upon them. What do you think of that? Think we'll ever be great?
I don't know how relevant greatness is for us, but that thrust part sure has relevance right now.
That's what you're working on, right?
That's right.
Yeah. Thrust is one of the four forces of flight. It's the force that pushes an airplane through the air. This force is needed to overcome the drag of the airplane. If the thrust and the drag are exactly balanced, an airplane will proceed at a constant velocity through the air, according to Newton's first law of motion. If you make the thrust greater than the drag, well, then the aircraft will accelerate, according to Newton's second law of motion.
Well, don't forget the third law also, because every aircraft pushes air backwards. That way, the aircraft ends up going forwards.
Sort of an action-reaction.
Absolutely.
I'll bet there's an equation that describes this.
Oh, you know there is. The equation for thrust is shown here. T, thrust, is equal to m dot, that's the mass flow rate, times v, the velocity.
You know, Orv, I think to help students, maybe we ought to give a little bit more detail about those terms in the equation. The first factor in the equation is m dot. It's the mass flow rate. So this is the amount of air that the propulsion system moves per unit time. Now, some propulsion systems, like propellers, or large propellers, move a lot of air. So they have a large m dot. Rockets, which usually have small diameter, usually will only move a small amount of air. They have a small m dot.
Altitude also plays a factor here. At high altitude, the decreased density of the air will cause the mass flow rate to decrease. It's not the volume of air, but the mass that is pushed.
The second term in the thrust equation is v, the velocity of air that moves through the propulsion system. This could actually be different than the velocity of the airplane. In propulsion systems like propellers, the velocity change is not really all that great. But with a rocket, there's a large increase in velocity coming out the nozzle.
So really you can see from the equation that an aeronautical engineer would have two choices to increase thrust. One is to move a mass of air, a larger mass of air, and the second would be to give that air a lot of velocity.
Now, either way that he does it, he's going to have to move the air to make thrust, doing work on the air. And to do work, he's going to have to expend energy in an engine of some sort. Engine will require fuel as well, and some sort of a mechanism to make the whole thing work together. The first attempts to do this were done with steam engines. Sir Hiram Maxim built a large aircraft in 1894 with two large flat propellers that were powered by two steam engines. This aircraft actually got off the ground but lacked control and crashed.
That's right. In 1903, we decided to use gasoline-powered aluminum block engine. We used our wind tunnel studies on wings to design propellers that were in essence rotating wings.
That's interesting because all modern propellers follow this same design feature. The things that make a wing efficient, long, thin, work as well for propellers.
That's right. With the development of jets in the 1930s, available thrust rose dramatically until the limits have become developing materials that are able to withstand the high temperatures of an afterburning jet engine. In fact, there's no other advancement made in aircraft development that's matched the improvements that have been made in thrust. It may be interesting even to note that with development of some new lightweight materials, it's now possible that human power alone can provide enough thrust to be able to fly.
That's an interesting looking design. It sort of looks like ours with the propeller in the back pushing the aircraft and the little canard out in front providing pitch control.
Some things are timeless.
We should mention again that in level flight, thrust works only to overcome drag. It does not create lift. It doesn't pick the airplane up. Unless you were to orient the propeller on top yeah, like a helicopter. The other part is that in a climb, there's a small component of the thrust, it goes by the sine of the angle, that can be used to oppose gravity as well.
Finally, when an aircraft is attempting to get into the air, thrust is also used to overcome the inertia it has and give the aircraft enough velocity to make the lift effective.
Yeah, back in 1903, we were able to take off under our own power at Kitty Hawk just from the thrust generated by our propellers and our little 12 horsepower engine. You know, or have I been thinking?
Oh no, don't tell me. You got another idea.
Yes, actually I have. It has to do with these propellers. Suppose we took the last 5 inches and put a large twist on there. What do you think?
Here at the end.
Yeah,
I think
yeah.
so. That might just provide that thrust we've been looking for. It might also solve that delamination problem we have.
Yeah, speaking of that, how is your hip?
Well, my hip's pretty good, but poor Selfridge.